All right, we're going to continue our discussion in terms of derivatives. So what we're going to be looking at is the derivative of exponential functions and how to treat exponential functions. Okay, now this section is pretty short. There's only two specific rules I want to talk about. So here's the first one. And we're going to look at the exponential functions. This essentially is what exponential functions look like. In this example, we consider here b is a constant. So we're talking about something that is a constant to the power of some x's there. So let's begin with a few examples there. Okay. Let's say you have f of x is equal to 10 to the power of x, and you have to find the derivative of that. So the derivative here is equal to, according to that rule there, first thing, you're going to copy the function exactly as it was before. Then you're going to multiply by the ln of the base. In this case, the base is 10. And then finally, you're going to do the derivative of the top. Derivative of the top function here. What is the derivative of x? The derivative of x is equal to 1. And that's it. So in this case, we have 10 to the power of x times ln of 10. And that is essentially the derivative. Now, they may try to confuse you and complicate things a little bit. So let's look at the second example here. What if we have f of x is equal to 8 to the power of 2x plus 1 to the power of 3? See how that works out. All right, we're going to look at this and we're going to process it exactly the same way we've done before. First, there's a constant, and then on top, there is some power of something there, where there is an x. So constant to the power of x's. So that requires to use the first property, the first rule there. So the derivative is, first, you're going to copy the function as it was before. We're not changing anything here. And then you're going to multiply by the ln of the base. And then the last thing we do is we multiply by the derivative of the exponent. Now, if you look at the exponent here, this is actually a complicated function that requires us to use chain rule. So in this case, we're going to say 3, 2x plus 1 to the power of 2, and then multiply by the derivative of the inside. Perfect. Now, if I have to simplify this, I can write this as 8 to the power of 2x plus 1 to the power of 3 times the ln of 8. And this other piece can be multiplied by 6 bracket 2x plus 1 to the power of 2. Awesome. And that's pretty much all it is there. I'm going to do a final example. This is the one that I find a lot of students get a bit confused about. So f of x is equal to something like that. X to 7 to the power of x times x to the power of 7. So a few things to note here. First, there is actually two things multiplied. First function is f, second is g. And because we're talking about two things multiplied, we're going to have to use a product rule. So I've written it down there. Let's walk through the product rule here. So the derivative of that is equal to, well, we're going to do the derivative of f now. The f function is an exponential function because it's a constant to the power of x. So we're going to use the rule that we just learned. That means we're going to copy the function, multiply by the ln of the base, multiply by the derivative of the top, which is 1. So that takes care of f prime. That is going to be multiplied by g, which is x to the power of 7, and then plus. The second part is we're going to copy the f as it is, and then we're going to deal with the derivative of g. Now, what is the derivative of x to the power of 7? Well, this is just the basic derivative, so 7 x to the power of 6. Perfect. Now, from there, you can simplify. We're going to try to see if there's a way we can factor what is common between those two functions there. Hopefully, you can see that. Well, I can factor out 7 to the power of x, and I can also take out x to the power of 6, because there's x to the power of 7 and x to the power of 6 there. So the common one is x to the power of 6. What am I going to be left with? On the first part there, I believe we're going to be left with ln of 7 times x. And the second part of the function there, we're just going to be left with plus 7. And that is essentially the derivative there. Okay, so that's the first exponential function there. How to find the derivative of those kind of exponential functions. Let's talk about the second type of exponential function. And in fact, this is pretty much the simplified version. It uses the same formula as before, but I would like to just illustrate this with specific examples on if the exponential function is e to the power of something. Okay, now what you're going to notice here, in my first example, if I'm talking about find the derivative of f of x is equal to e to the power of 5x. Well, e is a constant, so we could have just used the same rule as before and say, well, because this is just an exponential function, first thing we're going to need to do is to copy the function exactly as is. So I have e to 5x. Then you're going to multiply by the ln of the base, and then you're going to multiply by the derivative of the exponent. What is the derivative of 5x? The derivative of 5x is equal to 5. Now, what you're going to notice that is interesting about the exponential function with e is that ln of e is equal to 1. So in the most simplified version, this just becomes that times 5. In other words, I can write this as 5e to the 5x. So I've written down a simplified formula for dealing with e to the power of something. You don't have to worry about ln of the base, because we know the ln of the base is always going to be 1. So I would always suggest, if you're doing the derivative where it's e to the power of a function, just proceed to just jump straight to the final part of the question, the formula there, as I will illustrate in the second and final example in this section. So let's say if we have f of x is equal to e to the power of x squared plus 3x minus 1. All right, what is the derivative of that? Well, the derivative of this is equal to, first thing, we're going to copy the function exactly as is. Then we're going to multiply by the derivative of the exponent. What is the derivative of the exponent? That's 2x plus 3. And that's pretty much the end of that. Okay, let's do one last example. What if the question was f of x is equal to e to the power of 6 to the power of x, like that? There's a lot of powers going on there, but at the end of the day, as you can see, there is an e to the power of some function. So what we're going to do is we're going to use the rule for the derivative of an exponential function that has an e. So f prime of x is equal to, the first thing we do is we usually copy the function as it is. And then the second part is to do the derivative of the function on top. But if you can look carefully there, you will see that the function on top is also an exponential function. So I'm going to have to use the first rule that I gave you before. And this is the first property that we talked about here. Whenever you have a constant to the power of some x's, you're going to have to use that rule there. So in this situation, this is going to become 6 to the power of x times ln of the base, and then times the derivative of the exponent, which is equal to 1. And that will be the derivative of that. Perfect. exponential functions, derivatives, those are the two specific rules to remember. And there is always this sort of chain rule going on there. But as long as you can remember that, it should be pretty straightforward to apply some based on some of the questions that will be asked in an exam. Perfect.